Okay students, so I welcome you all for the first class of Karnataka CET. So in this class I am going to continue the differentiation for Karnataka CET with the synopsis. So first let us look through what is differentiability. Clear? So whenever you are studying, you have to be perfect with the theoretical things. For that reason, first we shall see what is differentiability. That means what is the meaning of differentiation, or what is the meaning of dy by dx. Clear? So if you know the meaning of dy by dx, then you can understand what you are doing. Whenever you are differentiating, most of the students are not knowing what they are doing with the given function. Clear? So for that, here what I will do, first I will explain the meaning of differentiation. Clear? So after that, let us continue with examples. Clear? Here you can see that let f be a real valued function. The meaning of f is a real valued function means f is a function from a to b. F is a function from a to b where a and b are domain and codomain. Domain and codomain. So here both of these sets are going to be real number sets. Clear? So if these two sets are real number sets, then we are going to call this particular function as real valued function. So that is the meaning of f is a real valued function. That means the domain and codomain are going to be your real number set. Clear? Next, defined on open interval. Already you have seen this type of intervals from your first year syllabus. So open intervals means the endpoints a and b are not included. Closed intervals means a and b are included. Clear? So here the function is defined on open interval. Please be careful according to this. Containing a point x naught. Containing a point x naught. Clear? That means you will be having an interval. You will be having an interval a comma b. You will be having an interval a comma b. From this they are going to choose one element x naught. From this open interval they are going to choose one element x naught. Clear? Suppose for example your interval is from 2 to 5. Here they can choose 3. Okay, like that. From the open interval a comma b, they are choosing one element, that is x naught. Clear? Then f is said to be differentiable. Then f is said to be differentiable at x naught if please say this, it is very important. Differentiable at x naught if limit x tending to 0, f of x naught plus delta x minus f of x naught divided by delta x. So let us understand this particular definition. If we understand this, I think you will be knowing what is the differentiation. Clear students? So for that, see here, I will show with graph. This is x-axis, this is x-axis, and this is y-axis. As you all seen, there will be a graph of every function f of x. There will be a graph for every function f of x. So whenever you are going to differentiate this f of x, you will write it as f dash of x. You will write it as f dash of x. Okay. So first let us choose f of x as this graph and let us see what is f dash of x. Clear? If this is your x-axis, they will choose one element, that is x0. They will choose one element from x0, that is your x-axis. What they are going to do, they will add some delta x. See this. This is your delta x, and this point will be x0 plus delta x. X0 plus delta x. Clear? So now corresponding to this particular points, here you are going to have your f of x, and here you are going to have f of x plus delta x. Are you getting my point? So whenever you calculate this limit, that is limit delta x tending to 0, f of x0 plus delta x minus f of x0 divided by delta x, what you are going to do, you are going to calculate the slope. Calculate the slope of tangent. You are going to calculate the slope of tangent at the point of x0. Please remember this point. In most of the exams, they can ask what is the geometrical meaning of dy by dx. This particular question has been asked in many exams, that is, what is the geometrical meaning of dy by dx? Means it is slope of tangent, drawn to the curve, Clear? So this thing is going to be very, very important to understand what is differentiation. So now I think that whenever you are going to find the f dash of x, in your mind you have to be fixed with, that is, f dash of x means slope of tangent to the given function, Clear? So this thing is very, very important. Clear, students? So that you are going to calculate here. I think you got the geometrical meaning of dy by dx, that is nothing but slope of tangent to the given function. Okay. So from this you have understood what is dy by dx or what is f dash of x clearly. Okay. So whenever this limit exists, whenever the given limit exists, see this, it is the given limit. If this exists, we say dy by dx is existing. Dy by dx is existing. Suppose this is not existing. Suppose this limit is not going to exist, we say we can't solve dy by dx, or dy by dx is not defined. Please make sure that this all points are going to be listened very carefully, because these things are very valuable words, because if you understand these all things, you can solve so many number of theoretical problems in your exam. Okay. So for that purpose, please remember that if limit exists, which limit? See here, they have given this. If this limit exists, your dy by dx exists. If this limit not exist, we say dy by dx is not found or not defined. Are you getting my point? Okay, clear. So now see here, if this limit exists, we call it the derivative of f of x at x naught. You can see here, we call it as derivative of f of x at x naught and denote it by f dash of x naught, or we write it by dy by dx. So what I have explained, they have given here, so be careful. Next, if limit not exist, we say that f is not differentiable, or we say dy by dx is not possible. Clear? Okay, from this introduction, I think you got the idea of what is the meaning of dy by dx. Now I will go for the next slide. Okay, here you can see equivalently limit x tending to x naught exists. That means nothing but your first principle method from your 11th class. First principle method of 11th class. Please remember it. Graphically, then the graph of f has non-vertical tangent line at x equal to x naught. So that is what we have already discussed in the previous slide. Say this, if this is the curve and suppose this point is your x naught where you are finding your dy by dx, this is going to be x naught minus delta x, and this term is going to be x naught plus delta x. Clear? So here you are going to find the limits. Here you are going to find the limits for your differentiable function. Clear? So both left hand derivative and right hand derivative are equal, then we say our function is differentiable, or we say the limit exists. Here the given limit exists. Clear? Suppose if LHD, that means left hand derivative, is not equal to right hand derivative, directly it says that this limit not exist. This limit not exist. That means first principle of your 11th class is not going to exist. Then we say that it is not differentiable. These all things are very, very important. Clear, students? So with this simple introduction of differentiation, let us see one of the very, very important conclusion. Please see this. Every differentiable function is continuous. Please remind this every time, because every differentiable function is continuous, but the continuous function need not be differentiable. See this, the continuous function need not be differentiable. That means f dash of exist, it implies f of x is continuous. F of x is continuous. Clear? Suppose f of x is continuous, f of x is continuous, but f of x may not be differentiable, clear? This is a very important result, because so many number of times on this particular result the question has been arised in your exams. They will give you one function and they say that it is continuous, and the following things are going to be to check it is differentiable or not. So if you see one of the example for this particular statement, it will be very good. So for that, let us see one example. For this, you have to be remembering that differentiable function is continuous, but continuous function need not be differentiable, clear? So for that, let us see one very famous example, that is f of x equal to mod x at x equal to 0. That means mod x is given and they are checking at x equal to 0. That means mod x is what? At x equal to 0. That means is it differentiable or non-differentiable? That they are asking, clear? So for that, let us see here. This is your right hand derivative. This is your right hand derivative. See, in the right hand derivative, they are calculating 0 plus. That means this is your 0, plus means your positive side, 0 minus means your negative side, clear? At this point, they are evaluating the mod x is differentiable or not. The mod x is differentiable or not, clear? So for that, first they are calculating the right hand limit. See here, f of 0 plus delta x, that means here they are substituting 0 plus delta x. If you add anything to 0, you are going to be remaining with what? The delta x. The remaining thing is your delta x, clear? So f of 0 plus delta x. See here, if I put 0 plus delta x in this x, here what you are going to have? You are going to have delta x. That they have written here, clear? So mod of delta x divided by delta x. Mod of delta x divided by delta x. They will cancel delta x and delta x. So your answer is going to be 1. Your answer is going to be 1, clear? So your RHD is 1. RHD is 1. Now let us see the left hand derivative. See here. On the same way, they have calculated the left hand derivative. And they have got -1. See this? Delta x divided by delta x. Whenever you move towards negative, on the negative side, the mod x will be negative. So that it is going to be minus delta x, because you can see here, as delta x tending to 0 minus this particular term. See this particular term, that is negative side of 0. Here delta x is lesser than 0. Here the delta x is lesser than 0. That means delta x is negative. Now if I cancel these two terms, your answer is going to be what? -1. Your answer is going to be minus 1. So you can see here your left hand derivative is minus 1, right hand derivative is plus 1. So as I said, if left hand derivative and right hand derivative is not equal, then it is not differentiable. Then it is not differentiable. Clear? Okay. So now you understood mod x is not differentiable at x equal to 0. Mod x is not differentiable at x equal to 0. From this, I am going to tell you one very important shortcut. Please make a note of this. One shortcut, that is whenever there are sharp edges like this, whenever there are sharp edges like this, at that particular points the function is not going to be differentiable. That means it is not differentiable. It is not differentiable at this sharp edged point. Very important, because in so many number of exams they will be giving the graph and they are going to ask you the particular things that where it is not differentiable. For example, here I can ask you, greatest integer function is differentiable or non-differentiable? See, this function already you have seen in 11th class, that is greatest integer function, you have already studied. But if you know this shortcut, then you can apply for this to your greatest integer function. How you are going to apply it for your greatest integer function? What they are asking, the greatest integer function is differentiable or non-differentiable. Here what you must know? You must know the graph of your greatest integer function. Like this function you have already seen in your 11th class. See this, here you are having the sharp edges. Here you are having the sharp edges. That means what? Definitely it is not differentiable at that sharp edged point. Definitely it is not differentiable at that sharp edged point. That means one thing you have to unlock here, the one thing that you have to unlock here, where these sharp edges are present, where these sharp edges are present. If you know the nature of graph, these sharp edges are present at integers. At integers. That means the greatest integer function is not differentiable at integers. See, I am not solving any problem here. I am not solving dy by dx. I am not calculating any limits. Just I am using the result. Just I am using the result of one important thing, that is, say this. I am using the result of this particular statement, that is, every differentiable function is continuous, but the converse may not be true. That is, continuous function need not be differentiable. Please remember this. On this definition or this statement, so many number of time that in the exam the problem has been asked. Like this, again I can ask about signum function. Again here you must know what is signum function. This is your signum function. Clear? So then where it is not differentiable, try on your own. Where it is not differentiable, you can try it on your own and you can get the conclusion. Clear, students? So from this we are understanding that to be in a differentiability, or to be in a or for the function to be in a differentiable, what the result has to tell, or what the function has to satisfy, how the function has to be, that you are going to understand from all this explanation. I think this much of explanation for the for introduction of your dy by dx is more than enough. Now let us continue with our next slide. Okay, so here let us see some of the formulas. Differentiation of some elementary functions. Differentiation of some elementary functions. Clear? See this. Differentiation of sin x is cos x. Differentiation of sin x is cos x. Differentiation of cos x is minus sin x. Differentiation of tan x is secant square x. Differentiation of cot x is minus cosec square x. Clear? So what I will do, I will give you one function. See, sin x plus cos x plus tan x plus cot x. Now what I will ask, find dy by dx of this. Find dy by dx. See here, all the functions formulas are present here. So from that you can choose the formulas. For sin x you have to write cos x. For cos x you have to write minus sin x. For tan x you have to write secant square x. For cot x you have to write minus cosec square x. Minus cosec square x. Clear? So my dear students, here note one point. Whenever there is c, there is negative. Whenever there is c, there is negative. Please note this type of points, because these things are very essential for remembering the formulas. Here also you can see differentiation of cosec x. See here, you have negative. Okay. So in trigonometrical functions, if it starts with c, you are having negative signs for the differentiable function. Clear? So you keep it in your mind so that it is going to be very helpful. Again, I am going to tell that differentiation of sin x is what? Cos x. Differentiation of cos x is what? Minus sin x. Differentiation of tan x is what? Secant square x. Differentiation of cot x is what? Minus cosec square x. Again, sec x is sec x tan x. Cosec x is minus cosec x cot x. Clear? So see this encircled values, because these points will help you to remember the formulas in your exam. Clear? If it starts with c, if it is a trigonometrical function, here the answer will be in the form of minus. Okay, d by dx of cos x is what? Minus sin x. I am talking only about differentiation. I am talking only about differentiation. D by dx of cot x is what? Minus cosec square x. D by dx of cosec x is what? Minus cosec x into cot x. Minus cosec x into cot x. Clear? So remaining terms are in positive, no problem. So that's why it will be very helpful for remembering the formulas. Clear? Okay. Now I will move to next slide. Okay. So here also there are some very important points. Please note them. Clear? Differentiation of x to the power of n will be n times of x to the power of n minus 1. This thing is well known to everyone. I think you all know the formula of differentiation of x to the power of n, that is n into x to the power of n minus 1. Okay. Then what about 1 by x to the power of n. See, they have given this formula. I am asking, what about 1 by x to the power of n? What you can say about the differentiability of 1 by x to the power of n? It is a very simple. It is a very simple one, but you have to understand it. See here, how can you write this? You can write it as x to the power of minus n. You can write it as x to the power of minus n, and you can differentiate it. Now tell me, what is the differentiation of x to the power of minus n? Again apply the same formula. It will be minus n x to the power of minus n minus 1. In the place of n, they have given minus n. In the place of n, they have given minus n. Just you note it and apply the formula. You are going to have minus n x to the power of minus n minus 1. So how you can write this? You can write it as minus n x to the power of minus is common, n plus 1. Minus is common and you can write it as n plus 1. So it will be equal to minus n divided by x to the power of n plus 1. See this. Very important point. Minus n divided by x to the power of n plus 1. Clear? So the formula for, note it in your notes, formula for d by dx of x to the power of minus n is minus n divided by x to the power of n plus 1. Minus n divided by x to the power of n plus 1. Please take a note of this and you can take help of it. Okay. Again, one more, d by dx of root x, because these all terms we are going to use in everyday mathematics. That means while solving some problems in mathematics, usually we use differentiation of root x, differentiation of x to the power of minus n and all. So that's why I am explaining these two formulas. That's all. Okay. So that means nothing but d by dx of x to the power of 1 by 2. D by dx of x to the power of 1 by 2. Okay. So d by dx of x to the power of 1 by 2 means what? Again you have to apply this particular formula. What it will be? 1 by 2 x to the power of 1 by 2 minus 1. Nothing but 1 by 2 x to the power of minus 1 by 2. That is nothing but 1 by 2 into root x. I can write this as 1 by root x. Clear? So that's why differentiation of root x, d by dx of root x is 1 by 2 root x. Note this formula also. It is also very essential and we are going to use it again and again in your regular classes. So please note this two formulas, that is x to the power of minus n and differentiation of root x with d by dx of x to the power of n. This is the main thing to calculate these two formulas. Clear? So please have this notes as well as watch it regularly. Okay. Next, I will go for d by dx of f of x to the power of n. See this, both are same. Here x is variable, here f of x is function. X is variable, f of x is function. Function in the variable x. The difference is here directly the variable is given, here the function is given. That means this is called composite function. I think you all know about it. Composite function. This is also very important. Composite function. So here they have given See here, they have given the formula for your derivative of composite function. Clear? How to differentiate this composite function? That means d by dx of f of x to the power of n. Clear? Again you have to use the same formula. See this formula. You have to use the same formula, that is n into f of x to the power of n minus 1. F of x to the power of n minus 1, and you have to multiply it with f dash of x. Very carefully you have to see this. You have to see it very carefully, because this is the formula that you apply here. But after applying this formula, you have to multiply it with the differentiation of f of x. Okay, let us take one example so that it will be very clear. See this. If I write some sin x square, this thing you have to differentiate. This is not sin square x. See, sin square x is not equal to sin x square. Sin x square is different, sin square x is different. Clear? Here f is sin. See this, f is sin. Next, x is x itself, n is 2. Okay, so it is in the form of f of x to the power of n. Okay, so if I differentiate this, if I want to calculate differentiation of sin x square, that means d by dx of sin x square, what I has to do? First I has to differentiate this f, that will be cos x square. Next I has to differentiate x square, that is 2x. So 2 times of x cos x square will be the differentiation of sin x square. Now let us see what will happen with sin x whole square. See this, what will happen for sin x whole square? This is nothing but f of x whole square. See this, it is in the form of f of x square, it is in the form of f of x whole square. Please make a note, sin square x is not equal to sin x square. Okay, so that you can calculate. See, sin square x is nothing but sin of x whole square. Sin of x whole square. These both terms are same. Clear? Now I will differentiate. Sin square x, that is nothing but sin of x whole square. Clear? So now I want to differentiate this. D by dx of sin square x. Clear? So what I will do, first I has to simplify this, that is 2 times of sin x to the power of 2 minus 1 multiplied with what? Say this, f dash of x. F of x, here it is f dash of x. In the place of f of x, what you are having? Sin x. Here it will be cos x. That means you are going to have 2 sin x into cos x. You are going to have 2 sin x into cos x. Clear? I think you got an idea of simplifying sin x square and sin square x or sin x whole square. Okay, this was an example of differentiation of f of x to the power of n, f of x to the power of n. I will take one more example. For your simplification, I will take one more example. Log of sin x. Log of sin x. I want to calculate d by dx of log of sin x. Okay. For that, see here. D by dx of, or you can see here, d by dx of log x is equal to 1 by x. D by dx of log x is equal to 1 by x. This is nothing but your x. Clear? If you see this formula, it will be very simple. Log of f of x. Clear? See this? I want to calculate differentiation of log of sin x. So if you see this, log of f of x, this is log, this is f of x. Okay, so from this, what you are going to solve, if this is y, see this formula, 1 by f of x multiplied with f dash of x, that means 1 by sin x. See this formula, log of f of x is 1 by f of x. So here I have to write 1 by sin x multiplied with differentiation of f dash of x. What will be differentiation of f dash of x? As you all know, differentiation of sin x is cos x. So this is your dy by dx. It is going to be equal to cot x. Clear? So differentiation of log sin x is going to be cot x. This is from two formulas. See here, this is one formula and this is another formula, which you have to be very careful while solving the problems, because they are composite function, so you have to be very careful. I will give you homework as cos x square, log of cos x. Try these two on your own so that it will be very clear. Okay, now let us go for the fourth one. D by dx of a raised to x. D by dx of a raised to x, that will be a raised to x into log a. See this, d by dx of a raised to x is a to the power of x into log a. For example, if I take 2 to the power of x, I want to find differentiation of 2 raised to x. What will be your answer? Dy by dx of 2 raised to x into log 2. See this formula, d by dx of a raised to x will be equal to a raised to x into log a. So that I am taking this example, so that differentiation of 2 to the power of x, differentiation of 2 to the power of x is going to be 2 to the power of x into log 2. Then what can be for 3 to the power of x? Check once again, what can be for 3 to the power of x? It will be 3 to the power of x into log 3. Are you clear? So again, it is a very simple formula, so that please remember it. very good friend of differentiation. Why it is very good friend? Because by differentiating, it's not going to change its nature. By differentiating, it is not going to change its nature, because if I differentiate e power x, again you are going to have e power x. If I differentiate e power x, you are going to have e power x only. Okay. What about e power f of x? Again of this kind. Composite function. What here you have to do? Differentiate this first with the formula of e raised to x. Differentiate it first with the formula of e raised to x. What it will be? It will be e to the power of f of x. Next, what you have to differentiate? Your f of x. That will be f dash of x. Clear? So again here, this is composite function. This is also composite function. This is also your composite function. Here they have given three formulas of your composite function. So please make a note of 1, 2 and 3. Be careful regarding these three, because other things are very directly. So if you are very careful of these three things, it will be very useful. Now let us move for the next slide. Okay. Here the differentiation of sine inverse x. See this minus sign. Differentiation of minus cos inverse x is going to be 1 by root of 1 minus x square. 1 by root of 1 minus x square. For both the formulas, for sine inverse x, you can write it as 1 by root of 1 minus x square. For cos inverse x, you can write it as minus 1 by root of 1 minus x square. Or for minus cos inverse of x, you can write it as 1 by root of 1 minus x square. These both terms are same. Are you getting my point? Sine inverse x and minus cos inverse x are going to be the same, but whenever you are writing cos inverse x, be careful about this minus sign. It will be minus 1 divided by root of 1 minus x square. Suppose it is minus cos inverse x. Suppose it is minus cos inverse x. It will be equal to 1 by root of 1 minus x square. Clear? Okay. On the same way, you go through the tan inverse x and minus cot inverse x. It will be 1 by 1 plus x square. On the same way, you can see the seventh one, sec inverse x and minus of cosec inverse x. Clear? For those things, you are going to have these two formulas. You just check them and take notes of it. Okay. So now let us look at the next slide, that is continuously differentiable. Continuously differentiable. Again, it is important. As we discussed, differentiable function is continuous, but continuous function may not be differentiable. On the same way, continuously differentiable. This statement is also very important. Clear? Let us see this. In this, we are having a function f is said to be continuously differentiable. Continuously differentiable if the derivative f dash of x exists. If the derivative f dash of x exists and is itself a continuous function. That means first it has to be differentiable. First it has to be differentiable and itself has to be the continuous function. Are you getting my point? Suppose if I give you one f of x, if the f dash of x exists, and itself f of x is continuous. Clear? So if the f dash of x exists and it is continuous, then we say that continuously differentiable. Are you getting my point? F of x has to exist with f dash of x, and this has to be continuous, For example, here you can see f of x is equal to x square sine of 1 by x. Simply I will tell, if I put 0 here, it will be not defined. Clear? Or here you can see that limit at extending to 0, or here you can see that limit extending to 0. If I put 0 here, 0 into anything is going to be equal to 0. 0 into anything is going to be equal to 0. Clear? For that, this particular function is going to be continuous. And it is going to be also differentiable. It is continuously differentiable. Okay. But see here, since limit extending to 0 f dash of x, please be careful with this. Limit extending to 0 f dash of x does not exist. I am telling that f of x is continuous, no problem. But f dash of exist will be with no limits. That means limit is not defined. Please be careful. Limit is not defined at, see this point, x equal to 0. That means f of x is continuous, f dash of x is not continuous. F of x is continuous, f dash of x is not continuous at x equal to 0. Why it is not continuous at x equal to 0? See here, limit exists with 0, so it is continuous, no problem for f of x. When you do differentiation, when you calculate f dash of x, what happens with it? See here, if I differentiate this function with product rule, u into v. Okay, with the product rule, if you differentiate it, first I will differentiate x square and next I will differentiate sine of 1 by x. So if I apply u into v formula, 2x sine of 1 by x is as it is. Next you have to write minus cos of 1 by x into x square, at x is not equal to 0. Are you getting my point? So at that particular point, limit does not exist and it is continuously not differentiable. Okay. So from this slide, you see this. All polynomials are continuously differentiable. Why all polynomials are continuously differentiable? You check it. Okay. So here, all polynomials, whenever you see a polynomial, for example, x square, x cube, 2x square plus 3x plus 1. On the same way, x to the power of 5 plus x to the power of minus 3 plus x square plus x plus 1. These all things are polynomials. So as we know the result, that is all polynomials are continuously differentiable. All polynomials are continuously differentiable. You can say that this all polynomials are continuously differentiable. Clear? Okay, now let us move to the next slide. Differentiation of implicit functions. So in this class I am remaining with 5 minutes. So in this 5 minutes I explain what is implicit function. What is implicit function? So that in the next class we can see how to differentiate these particular functions. Clear? So implicit function. See this implicit function. F of x you all know. Here the variable is 1. For example, sin x. Now I will write f of x comma y. This is the function with two variables. This type of things are called as implicit function. Clear? See here. To find dy by dx when a differentiable function y equal to y of x satisfies the equation f of x comma y equal to 0, we differentiate f with respect to x considering y as a function of x and solve the resulting equation to obtain for dy by dx. That means here if you don't understand this particular thing, please listen my explanation, so it will be very easy. What they will do, they will give you the function with two variables. For example, x plus y square. X plus y square is equal to 0. Say this. F of x comma y equal to 0. See this. F of x comma y is equal to 0. I have taken a simple example, that is x plus y square. Now I want to differentiate this f dash of x comma y. As you all know, differentiation of x is what? 1. Differentiation of x is 1 plus what is differentiation of y square? It will be 2 into y dy by dx is equal to 0. Clear? So after this, if I take 1 on LHS, it will be dy by dx equal to minus 1 divided by 2y. If I simplify this equation, you take 1 on this side, it will be minus 1. So you take 2y on the LHS, it will be minus 1 by 2y. Clear? If you don't know, see here, 2y dy by dx, it will be minus 1. Next, if I take 2y on this side, it will be dy by dx equal to minus 1 by 2y. From this, we got for dy by dx. Clear? But here, all students will be very doubtful regarding this particular step. How this 2y dy by dx? Why it is dy by dx? They are asking. Okay, I can explain you that from composite function. From composite function. Now, if I take sin x and if I differentiate with respect to x, see this, I know differentiation of sin is cos x multiplied with, if I differentiate this x, that is going to be dx by dx. Here I am going to cancel this 2. and it is going to be remain with cos x. Every time we won't explain this, we are not going to write this because it's a default thing. Clear? So for that we are not going to write dx by dx and cancel it. Directly we are writing cos x. Are you getting my point? Cos x into 1 will be again cos x. Clear? Suppose if I take sin y, what you are going to have if I differentiate with x? You are going to have cos y into dy by dx. See this? Like this you are going to have. Okay, cos y into dy by dx. That's why here for y square, first if I differentiate y square, it will be 2y. Next it will be dy by dx. I think the doubt is cleared. So for today, let us close the class. It's all of 1 hour time class. So I will close it. Tomorrow, let us continue with this session. So in the tomorrow session, I am going to explain this implicit function in detail. So be not tomorrow, mostly it will be on the next class, that is on 4th. So on the 4th, let us meet again on let us continue with implicit function. Clear?